Hello, and welcome to my video. My name is Rotimi Jasa, and today I will be talking to you guys about the mole. So, what is a mole, you may ask? Well, think of a mole as a representation of a number. Just like how a dozen means 12, the mole is a representation of the number 6.02 times 10 to the power 23. And an interesting fact about a mole, it's also named Avogadro's constant, and basically it was named that because a scientist named Avogadro originated the concept of this number, the mole, but however did not live to see the actual representation. Okay, so to find moles, use this formula. N is equal to N times Na. So that means the number of particles in a molecular compound is equal to the number of moles times Avogadro's number. And so let's do an example of that. Alright, here we go. So a sample contains 1.25 mole of nitrogen dioxide. How many molecules are in the sample? So to figure this out, we need to find the number of molecules. So we use this formula right here on top. So basically, when you plug in the data, so this becomes 1.25 mole times, this becomes 1.25 mole times 6.02, which is Avogadro's number, times 10 to the power 23. Or there are 7.52 times 10 to the power 23 molecules and 1.25 mole of nitrogen dioxide. Alright, now that we know how to find the amount of molecules in a question like this, I'll show you guys how to find the amount of atoms in a question like this. So, to do that, what you do is you take the amount of molecules from the last question and you times that by 3 atoms per molecule. So where this 3 comes from is that in a molecule there are 3 atoms: the proton, neutron, and an electron. So that's where you get this times 3 part. And so that gives you this 2.26 times 10 to the power 24 atoms. So therefore there are 2.26 times 10 to the power 24 atoms in this equation or question. Alright, so rearranging the formula. So a lot of times we won't get questions like the one that I've been previously telling you guys about. So we might get something like this. How many moles are present in a sample of nitrogen dioxide made up of 7.52 times 10 to the power 23 molecules? So to do that, we need to rearrange the formula. So instead of the multiplying the number of moles times Avogadro's constant, we'd instead divide the number of molecules, which is given to us in the question, by Avogadro's constant. So that would be 7.52 times 10 to the power 23 divided by 6.02 times 10 to the power 23. And so once you do all the calculations, you end up with 1.25 mole of NO2. So that question is pretty easy. So there's basically only 1.25 mole of NO2 in this sample. Alright, so the next thing I want to talk to you guys about is molar mass. Molar mass is a very simple concept. So basically, to find the molar mass of a single element, all you do is get the atomic mass of the element, which is found on any periodic table. So the molar mass of hydrogen would be 1.0079 grams per mole. The molar mass of lithium would be 6.941 grams per mole. And so basically, to put this in the way you'd write this in the formula, so I do that for sodium here. So you just write the molar mass, which is represented by capital M, and you write the subscript of the element. So the element in this case is sodium, so I wrote a subscript of Na, and that is equal to 22.990 grams per mole. Alright, so now that we know how to find the molar mass of single elements, let's move on to how to find the molar mass of compounds. So to find the molar mass of beryllium oxide, what you do is you get the molar mass of beryllium and you'd add that to the molar mass of oxygen, and that gives you 25.01 grams per mole. Next on the list, the molar mass of carbon dioxide. So what you do is you'd add the atomic mass of carbon, which is 12.01, to oxygen, which is 16.0, And so basically, the thing about this one that's different than the first one we did is that there are 2 molecules of oxygen in this molecular compound. So basically, what that means is that we have to multiply the amount of oxygens by 2, which I've done here in the equation. And so once you've done all the calculations, the answer you get is 44.01 grams. Thank you for watching this video, and so now my partner Rohan will go into more detail about molecular mass.
Hey guys, welcome to the second part of the mole conversions video for YouTube Monday. My name is Rohan Sariq and I will be teaching you about molar mass. Now, in order for you to be successful in calculating molar mass, you will have to understand what molar mass is. Now, what is molar mass? Molar mass is the mass of 1 mole of any element or chemical compound. So basically, molar mass is the mass of 1 mole. A mole is a unit of measurement to express the number of particles of a substance. So 1 mole is basically Avogadro's number, 6.02 times 10 to the 23 particles. Now you can say this in many other ways, like our team we talked about earlier, there's 6.0221, etc. But just use 6.02 times 10 to the 23. Now that's 2 decimal places. So let's practice. Nitrogen. The symbol of nitrogen is N. Nitrogen's atomic mass is 14.01 according to the periodic table. Now, as you can see, nitrogen is right there. It has a atomic mass of 14.00674, rounded to 14.01. Now, 1 mole of nitrogen molecules weighs 14.01 grams. So 14.01 grams per mole basically means that 1 mole of nitrogen weighs 14.01 grams. Now let's move on to something harder. Let's practice it. Let's practice hydrogen chloride. Hydrogen chloride is made up of hydrogen and chlorine, which makes hydrogen chloride, HCl. Now, hydrogen has an atomic mass of 1.01, and chlorine has an atomic mass of 35.45. I'll show you guys on the periodic table. Hydrogen has a mass of 1.00794, rounded to 1.01, and chlorine has a mass of 35.4527, rounded to 35.45. Now, let's move on. So, you take the atomic mass of hydrogen, which is 1.01, right here, and you put that into the first thing for the equation, and you take chlorine, which has an atomic mass of 35.45, and you add it to the hydrogen's atomic mass, which is right there. And once you add it together, you get 36.46 grams per mole. Now remember, you cannot forget to write grams per mole, as 1 mole weighs 36.46 grams. That's basically what it means. Now let's move on to another practice question, which is a little bit harder. Iron 3 sulfate. Now, iron 3 sulfate is made of iron, sulfur, and oxygen, which makes Fe2SO4 3. Now, sulfate is a polyatomic ion, so it contains sulfur and oxygen, SO4 3. Now, iron, Fe, has an atomic mass of 55.85, and as you can see after iron, it has a 2, which means there are 2 atoms. Now, sulfur has an atomic mass of 32.07. That means that on the periodic table, the atomic mass is 32.07. And after sulfur, you can see outside of the brackets, it shows a 3, which means that whatever's in the brackets has to be multiplied by 3. Sorry. So sulfur has an atomic sulfur has 3 atoms. Now, oxygen has an atomic mass of 16, and there are 12 atoms. Now there are 12 atoms because whatever's on the outside, like I said earlier, is multiplied by the number of atoms inside. So you take 4 times 3, which gives you 12 atoms. Now, these are straight from the periodic table. So you add them all together. So you take 55.85, which is atomic mass of iron, and you multiply it by how many atoms there are. There are 2. Now you take the atomic mass of sulfur, which is 32.07, and since there are 3 atoms, you multiply that by 3, and you add it onto iron's atomic mass. And then you take oxygen, which has an atomic mass of 16, and you multiply whatever's outside on the inside, 3 times 4, and you get 12. So you do 16 times 12. Now, once you put that in the calculator, you get 399.91 grams per mole. Now, last one, let's do something that's quite hard. Let's practice ammonium phosphate. Ammonium phosphate is made of nitrogen, hydrogen, phosphorus, and oxygen, which makes ammonium phosphate. Now, nitrogen has an atomic mass of 14.01, and it has 3 atoms. As you can see, the 3 outside of the brackets, like I said earlier, you multiply that by whatever's inside. Now, hydrogen has an atomic mass of 1.01 with 12 atoms. As you can see, like I said earlier, you multiply the 3 by the 4, and you get 12. Therefore, hydrogen has 12 atoms. Now, phosphorus has an atomic mass of 30.97, straight from the periodic table, and it only has 1 atom, as there is 1 hiding in there, but you don't write 1. And oxygen has an atomic mass of 16 with 4 atoms, as you can see the 4 right there. So now, once you add these 4 together, you get 14.01 times 3, since it has 3 atoms. You get 1.01 times 12, which has 12 atoms for hydrogen, and you get 30.97 times 1, which you don't have to write, but I'm just showing you for the video purposes. It only has 1 atom, so you multiply it by 1. And oxygen has an atomic mass of 16, so you do 16 times 4 since it has 4 atoms. And the answer is 149.12 grams per mole. I hope you learned something new from this video, and I hope you can calculate moles and molar mass now. Thank you for watching.